So in this video, we're going to talk about converting position versus time to velocity versus time graphs. And in order to do that, we're going to have to figure out what the velocity is at a given point in time. So if we look at our first graph here, we will see that we have a bunch of different stages, a bunch of different velocities. We have 1, 2, 3, 4, and 5 different velocities we're going to need to find because, again, velocity is rate of change of position, and that's going to be determined by the slope of that position versus time graph. So if we now go back and try and find the slope of the individual sections, we're going to start in section 1. Section 1 goes down a total of 6 meters, and it takes 3 seconds to do that. Notice the scaling over here, we're going up by 2 for each block. So we have negative 6 meters in 3 seconds. That means our velocity or slope is going to be negative 6 meters, 3 seconds, or negative 2 meters per second. So now we'll go to our velocity graph, and we will add that velocity down here at negative 2 meters per second for 3 seconds. Going back to our position graph again, now we're going to look at the second section. Here we have a rise of 2 from here to here, 2 meters. We have a run of 2 seconds, so that's going to be a velocity of 2 meters in 2 seconds, or plus 1 meters per second for those 2 seconds. So back to our velocity graph, and then boom, we will add that velocity here at plus 1 meters per second for those 2 seconds. Now we'll go back to our position graph again, kind of repeat the process. Here we have a run of a rise of -4. We have a run of 2 seconds. So if we do negative 4 meters divided by 2 seconds, we're going to get a velocity of negative 2 meters per second for those 2 seconds. So we go back to our velocity graph, and boom, we'll add in that velocity of negative 2 meters per second for 2 seconds. Going back again for our fourth section. Here we have a rise of plus 6 meters. We have a run of 2 seconds. So if we do 6 meters divided by 2 seconds, we're going to get a velocity of 3 meters per second. We'll go back to our velocity graph, and for those 2 seconds, we now have our velocity up here at plus 3 meters per second. Last section, finally made it. We have a run of negative 2 meters, a rise of negative 2 meters. We did that in 2 seconds. So our velocity is going to be negative 2 meters over 2 seconds, or negative 1 meters. Oh, sorry, this is only 1 second. Haha. So negative 2 meters in 1 second, meaning we have a velocity again of negative 2 meters per second for that last second. So if we go to our graph again, we see that we have yet another line at negative 2, but this one is only 1 second long. So there's the whole concept. Again, break it down into its individual slopes, find those individual slopes. Because those slopes are going to be constant, we're going to have horizontal lines on our velocity graph because the slope is the same for those entire segments. It changes throughout because we're changing speeds and we're changing directions, but for the sections where it's moving at a constant rate, a constant slope, we have those horizontal lines everywhere in our graph. Now it's your turn. You'll have some questions to answer based on this position versus time graph.